Yeah. Just to address Amaya's issue. You all hearing me clearly, or is it breaking up a little bit?
I hear you clearly for the most part.
All right. Okay. Because where the signal is not the strongest, so we might have some issues going forward with that. Anyway, right. So as I was saying, attenuation is the ability for a signal to maintain its integrity over distance. So what we mean by that is that the further away a signal moves from the source of that signal, is the more likely it is for the integrity of that signal to be compromised. So again, and of course, every signal has its limits. So if it is that we have a wired connection, and let's say we're using Cat5 cable, then anywhere between, depending on the quality of the signal and the strength of the signal, the quality of the cable, etc. Anything between 30 to 100 feet is, best case scenario, you might get about 100 feet of signal, where you don't get any issues, or worst case scenario, you might have about 30 feet before the signal, starts to break up, or parts of the signal gets lost. The same thing for wireless communications. So, in terms of the specific distances that, let's say if you have your Wi-Fi router, some of us, and of course, attenuation is affected by objects in the middle as well. So even if you have like a Wi-Fi router in your house, right? Let's say this is a top-down view of your house, and let's say this is your living room here, right? And there's a kitchen here, and let's say you have a bedroom there, maybe a little study here and a bathroom here. And let's say, for instance, your router is here in the study, right? Um, the signal will go out through the house, but there might be certain places, if you in your bedroom and you have your computer here, you might notice that because of the interference from the walls, the solid concrete walls, that you might have problems getting your Wi-Fi signal at this location in your bedroom, as opposed to maybe this location in your bedroom. The same thing, we could have the same router, and let's say, for instance, we're in a concert hall, and this is the stage, and this is the router, but the concert hall does not have any. All it have is seat and the stage here, and the router is pushing out its signal, right? Everybody inside of here from front to back would be able to get a connection onto that router without issue, right? Even though it's the same amount of space for both places. So we could see that attenuation could be affected by obstacles. This makes sense to you all?
Yes, sir.
Yeah. Okay, good. So um, right. So one technique that can be used to fix signal attenuation problems on a network. How would we fix problems? The most obvious response to that is, if your signal is getting low, what would you want to do with the signal? You might want to, or let's see if we can identify two things. One thing might be to use a repeater, right, to boost the signal, so that it can travel further. So that's one thing that we could do. And of course, another thing that you could do to fix signal attenuation problems is to, for wireless networks, place the source central to the area to be serviced. So if it is that I have a wireless network, I might want to simply, I might simply just want to, again, if I have like a large area for a wireless network, right? It would make more sense to see if I could put the signal somewhere inside here so that the signal could go out in all directions, as opposed to putting the signal, right? I'll use a different color, as opposed to putting the source, sorry, not the signal, in one corner, and past that point, you're not getting any signal. You understand where I'm coming from with this?
Yes, sir.
All right, good. So we have Pelican, a small business with 5 desktop computers, a network printer, several files which need to be shared, and access to the internet is seeking to set up a network. Draw a diagram to illustrate how this network could be constructed. Note that all the computers should be able to access the printer, shared files, and the internet. So what can I do on this network? What could I do on this network to what could I do to set up this network so that everybody has access to all of the resources? Okay, we need to be able to access the internet. So if it is that we have a switch, hold on. All right, folks, give me 2 minutes, right? Yes. So, okay, so if we have 5 desktop computers, what we could start off with is that we could start off with a switch. And this switch could have all of our desktop computers. So I'll put PC1, right, PC2, PC3, PC4, and PC5 are all connected to the switch. So we also will connect our network printer. Right, so we have our network printer connected, and via the switch, every computer here will have access to this network printer. If we have a file server, we could also place the file server on the switch. So again, all of the computers have access to the file server. Now, in order for us to access the internet, right, we will have to have the switch connected to an internet router. And this internet router will be connected to the internet. So this is the diagram that they basically looking for, right, to illustrate how the network could be constructed. All of the computers are on that layer 2 device, right, a switch, and then because all of them, along with the network printer and the file server, because all of these are on the same network. And then what happens is that this switch is connected to an internet router, right, which allows for all of the devices on the network to share that internet connection as well. The internet router, of course, is going to give us our connection to the internet through our ISP. So once network traffic is leaving from a computer to go to the internet, it will pass through the switch, and the router will be concerned, the router, which is a layer 3 device in our OSI model, our router is going to allow us to access the internet. Thank you. Any questions?
No, sir.
All right, so we can move on to the next one. Everybody, well, I mean, once you did this, you had something similar to this. Anybody had anything different? Check the. Right, a switch is kind of like a hub, except a hub is a dumb device, and a switch has circuitry which manages the which manages how traffic is flowing in a network. So a switch is actually a smart device, and a switch allows for multiple computer connections so that they can be internet worked. But a switch does not allow for, or it minimizes collisions with respect to multiple computers sending data at the same time. Is that answer your question? Yeah?
Yes, sir. Thank you.
All right. Right, so let's move forward. No, a switch is a network device. You all spoke about switches in the same presentation that you all made. That was one of the devices that you all had in the PowerPoint, not so? Was it not one of the devices you all had in the PowerPoint? Nobody was in who was in that group could answer me.
So I don't know if it was their group, but I know my group did switches because, and the reason I know that is because I did switches.
Right. All right. Well, everybody should have been and it was being spoken about, but that's all right. Sometimes we have those moments, and what matters is that we know now. All right. So based on your diagram, briefly describe how printing, file sharing, and internet accessibility would be possible. All right. So in all of these cases, right, in all of these cases, the switch is because we have made a star network with the switch, and right, so printing and the network printer is connected, all devices can print over the network. All right, so because we have made a star network with the switch, network is connected, all devices can print over the network. Sharing. How can file sharing be done? What we did there was that we have two ways that file sharing can be done. In our network, right? So in our network, file sharing can be done via sending files directly or through or sorry, let me say via putting it on the file server connected to the network. So we end up with two solutions for file sharing, right? Because of the fact that we had this network here, and then we also have a dedicated file server. So if you want to put it up in such a way that anybody can access it, you could put it on the file server. Or if you want to do a PC to PC, a computer to computer connection, then we should be able to do it like that as well, okay? And internet accessibility, right? The internet router is directly connected to the switched network. So all devices on the network can, right? So all devices on the network, sorry, can access the internet. Any disagreement with that?
No, sir.
I'll take it. Yeah, I'm about to say I take it the fact that everybody's quiet means that, you know, we have no disagreements. Sole, was your group in charge of this in terms of mobile technologies, in terms of speed, LTE, CDMA, GPRS, GSM? Were you in that group? Sole, I was asking. We don't have,
So
you're not there?
I'm sorry.
I know, I thought so. She's not? Seeing her name in the list? All right, well, anybody else then? What is the, in terms of speed, from the slowest to the fastest?
So I think GPRS is the slowest. Then I'll
Right.
say CD.
GPRS.
Right. Then
Then,
CD.
what was the second one you said?
CDMA, sir.
CDMA.
Then GSM and then LTE.
GSM and then LTE. All right. You sure? I just want to check and make sure. I think you're correct, yeah? But let me make sure CDMA versus GSM in terms of speed. Correct with that, you know? Yes, because CDMA, GSM, sorry, evolved faster than CDMA. Right? So, and we spoke about, did you all, well, yes, we did speak about CDMA being code divided multiple access, right? Where data is encrypted and sent over a signal as opposed to GSM, which is a layer on top of TDMA technology, which uses time division mobile access, right? Which allows for everybody who is sending data over the network to get a slice in terms of a time slice in terms of being able to send data and receive data. Okay, so two advantages of a centralized network over a decentralized network. A centralized network versus a decentralized network. Hello?
So
Alexa, I want
never
to
mind.
justify that quicker decision-making statement. I don't fully understand it.
Well, I thought since there's only one person who like planning and setting the goals, that it would just be like a straightforward approach instead of having like a board of directors and everybody coming to consensus.
Nah, I think you're thinking about like an organization. This is computers interacting with each other. Yeah, right. Good. So yeah, so this is not. Remember, you're not thinking of it in terms of people. Chevelle, yes. Chevelle is correct. There's easier maintenance, right? So we're thinking about, when we think about a centralized network, you think about one central server and many connected clients. Okay? And the thing with this is that this is easy to set up and maintain. This is easy to set up and maintain, and it's also easy to control, right? So it's easy to set up and maintain. Right? And it's easier to administrate. Because the clients must adhere, right? The clients must adhere to the server's rules. And there is one defined server and many defined clients. But in a peer-to-peer network, so this is your centralized. But in your decentralized network, right, everybody acts as both a client and a server. And what happens is that in terms of moving data around, it could be very difficult or very easy to, it could be very difficult or very easy to send messages, right? Because in terms of tracking and in terms of maintaining security, etc., a centralized approach is much easier than a decentralized approach. But the difference is that if there is any sort of outage of the server, all of the clients are without service. Whereas in a decentralized network, if one node goes down, there are still possibilities for the majority of nodes to share data and access data, etc. But the thing is that logically, it's difficult because all of the nodes, or let's just go with the most basic, all of the nodes might share the same authority or precedent. So if everybody is acting both as a client and a server, in terms of maintaining rules across the network, it could be difficult. That makes sense?
Yes, sir.
So you
Yeah.
Right. Mm-hmm.
please.
What was that?
That's the last part.
I said in terms of maintaining rules across the network, right? Because everybody acts as both a client and a server, it could be difficult to maintain or adhere, or enforce rules, especially when a rule maybe has to change across the entire network. Because you have to check now to ensure that all of the connected nodes are following the same protocols.
Okay, sir.
All right. All right. So I'm going to move to the 2009, which we wanted to do, which I started, well, talking about last week. But then oops, did my screen go blank?
Yes, sir.
Yeah, sorry about that. I clicked the wrong thing.
Okay.
Yeah. Give me a second and we will start on 2009. Right? And again, I think I might do question 5 and 6 with 2009, and then we'll move forward. Right? So we'll do question 5 and 6, and then do question 4 and 3 and come forward with it as we go in terms of our review. Okay? Anybody else timer on their team stop running? You know, the timer to see how long class running.
No, sir.
Uh-huh. Mine's stuck at 7 minutes and 44 seconds. I don't know. Yeah. All right. So we started. This is one of the old papers where we didn't have space to write it. Yeah. That movie Tenet. I have to watch it still. Is it good?
Compared to
What
other
did you say?
Hollywood movies, yes. But is it accurate? And would you understand it? No.
Probably not.
So don't waste my time then.
And I watched the soundtrack file, and it's have a cool concept.
Okay. All right. All right. So briefly explain how each of the following features can aid in network management. User accounts and access logs. All right. So maybe I'll just cut, and then we'll type out the answers. All right. So to a new page. So how do user accounts and access log aid in network management? I hope this is just not me talking and answering the questions and you guys have things to contribute and stuff like that. So user accounts. How does user accounts aid in network management?
So because user accounts serve as a way to identify people who enter the server.
Right. So it allows for identifying users and maintaining levels of access control, right? For various applications and locations on a network. Because I could, if I'm the administrator, or if, maybe Alexa is a super user, but Collins and Tarek are just normal users. There are certain applications that we wouldn't want them to be able to execute across the network, or maybe certain locations that they're not supposed to go on the network. Okay, so user accounts allow for us to be able to say who can go where and who can access what on a network. And what about access logs? How do access logs allow us to
Record to enter the system.
Right, these record events across a system and tells us who accessed what and when it was accessed. Okay? And this is very good for, like, you know, tracking and seeing, well, all right, maybe afterwards somebody you know, did something on the system. Let's see who it was that did a particular, or you know, did a particular thing on the system that caused an error on the system. All right, so let's move on to the next one. Right. So the first 4 layers, we want to state the first 4 layers of the OSI model for computer communication. And then we want to explain how each of the layers are involved in the transmission of a large file. So let's get this here. All right. So we want to talk about the first 4 layers. We have our mnemonic. And let's just, maybe we could just for this, because it makes sense, right? Let's go 1, 2, 3, 4, 5, 6, and 7. We have our mnemonic, right? Plenty dogs need to secrete.
The physical layer.
Okay, yeah, always. And by having the start in here, we could, of course, say yes. This first layer is the
Physical
layer. The next layer is the
Data link.
Data link layer.
data link layer. Next layer is the
Network.
network layer. Then we have
Transport.
transport, then session, then what?
Presentation.
Presentation, and then
Application.
application. And it is important to note that the layer 1 is always the physical layer. Layer 7 is always the application layer. Okay?
Yes, sir.
Yeah. So what goes on at the physical layer? Or let's say we have to transmit a large file. Maybe we could start with the application layer and go down. Right? So your application layer, let's just talk about what would happen at the application layer. Right? If I wanted to send a file. The application, maybe we would use, right, some application specific protocol such as FTP would be used to, right, send a file. What would go on at the presentation level? The file would be encoded in a way that the receiver can understand the file. Okay, for the session layer, what would happen? Connection to the destination would be established. You're hearing like a TV in the back?
Not that much, sir.
Okay. Yeah. All right. So a connection to the destination would be established, right? For sending the data. What goes on at the transport layer? Right? Or maybe we could now start at layer 1. Right? You have this large file, right? The file would be sent as signals, right? As electrical signals or radio waves to the destination. The data link layer is always responsible for creating data frames. What are data frames? Small chunks of the data to be sent across the network. Okay? What goes on at the network layer? Right? The data frames would be addressed as, right, to send from one network to another. All right, and the transport layer checks to ensure that the packets are safely across the network. Right, checks to ensure that the packets are safely across the network, right? Of course, if you're using TCP. Okay, so this is just what would happen at each of the layers if we had to find, you know, if we had to sort out what would have been done, right, in terms of sending a large file across the network. So a connection to the destination would be established and maintained for sending the data. Did you all watch my videos that I sent? The videos with the guy? I know that the videos were a little, you know, it wasn't most exciting, but it was pretty interesting, yeah?
Yes, sir. Oh, watch that one.
All right, so Zaria, watch it. Anybody else?
I just watched. I just read the notes.
Okay.
In classroom.
Okay. All right. Now, as I said, especially for the OSI model, I think that the guy explains it well. Right? So I think that the guy explains it well. So I don't really think that we have any sort of excuse for not being able to say. And then we do have notes alongside this, right? Our own class notes that we made. So, we should be able to get, this is a 10-mark question, right? That is almost, that's like what? About 6% of your entire examination being able to get a question like this correct. So it's really important that you all are able to answer this question. Okay? No problems?
Yes, sir.
All right. So next up, explain how data are communicated in IEEE 802.11b network. Use a diagram in your response and then distinguish between the CDMA and TDMA for methods for mobile networks. So let's take these two. All right, new page, and put it down like that. Right, so we have explained how data are communicated. Right, so if we have a 802.11b network, right? 802.11b network, that's a what? What do we mean by 802.11b? Hmm? Yes, Krista, so. Hmm?
I know it's slower than AC or Airwave or something.
Okay. Right. So first of all, let's say what the 802.11b is, right? So 802.11b is the wireless, right? Or we could just use Wi-Fi standard. Is the Wi-Fi standard, or is a Wi-Fi standard for data communication, right? Data is transmitted to a Wi-Fi router. Data is transmitted to a Wi-Fi router manually. Sorry, not manually. What am I saying? Via a cable, and then the analog signal is converted to a wireless radio signal at 2.4 gigahertz. Okay, so this is question C answered here basically, but they say that they want a diagram. So really and truly what we could do is that we could just simply illustrate it by saying, all right, we have a wireless router here, right? You have your wired connection and your Wi-Fi router, right? Right, so this is the internet. And we could have a device like a cell phone or something, so, or a tablet, whatever it be. And this is connecting via here. All right, so we have the tablet. We have the 802.11b Wi-Fi router. And it's connected, of course, to your internet. Right? And this would allow, this is our communication here happening wirelessly. Right? So we have our wireless communication. We want to distinguish between CDMA and TDMA access methods for mobile networks. Right? Now notice that this is just a 2-mark question. So really and truly, they don't want any sort of dissertation for this question. This question is a basic question. What is the difference? This question for 2 marks, really and truly, they're asking really what does the C stand for and what does the T stand for. So we have CDMA and we have TDMA, right? And CDMA, right, it stands for code division multiple access, and TDMA stands for time division multiple access. And CDMA, and truly, provides a constant connection to the wireless network and encodes data for communication. Whereas time division multiple access, right, grants each device connected to the mobile network access via time slices, which is when data communication is processed. Okay, and that's good enough. So we have CDMA access and TDMA access. Now, I am not lying to you. We can go further and explain CDMA and TDMA. For the purposes of CAPE, they don't want to know much more than this. And telecommunications is very complex, right? CDMA is actually very, very complex. It's actually, because you are encoding it into a signal, right? You know, it really and truly looks at, well, what is, essentially you get into a bit of cryptography there in terms of sending signals, because you are encoding a signal. Whereas the TDMA allows for, you know, waiting for a specific time and being able to send your data. Your data could still be encoded, right? But it's not encoded into a larger signal where the destination of what you want to encode, sorry, the destination of where you want to send the data, etc., is located. Everyone is with me here?
Yes, sir.
Yes, sir.
All right. All right. All right. Let me just call Jeremy here with me. Jeremy, you could raise your hand or something. So if you're with me, right? And I still seeing Sole in class, but I ain't hear from her yet. Sole, Jeremy, y'all could give me a hand raise if you're with me. Victoria, okay, I see Sole. Sole, give me a sign of life. All right. He says, say Jeremy left to go wash a plate. All right. All right, Victoria, you with me? Kashana, Sharice.
I'm with you, sir.
All right, Kashana is here. Sharice has put up her hand. Chevelle. I ain't hear nothing from Chevelle. Chevelle, you with me? Okay. All right, so let's take a 10-minute break, and then I will join you back at 2:10. So we're gonna resume class at 2:10. Okay.
Yes, so
All right, sir.
All right.
Okay.
No problem. Krista, you can pause the recording. All right, we're back. You all with me? You all with me? Anybody there?
Yes, sir.
All right, good, good, good. All right, yes, okay, okay. We still have 2 minutes to go. I'm gonna share with you all an article that I just came across that has nothing really to do with ComSci, but I just found it was very interesting in terms of its content. I didn't even know such a test was possible. I've put the link to the article in the chat. Anybody take a look at the article?
Yes, I'm reading it right now. Oh, yeah,
But
good.
apparently the Japanese government requested the same thing too. That they stop testing them like that. Apparently China is convinced that it's probably like more accurate or something, so I don't know.
Accurate, yes.
Yeah. So rather than swabbing your throat, here's another by the Washington Post. Yeah, Tarek, you can ask the question at the end. Uh, all right. Zaria, I do not know. Yeah, you can read the article and see. You can, if any of you all into biology or anything, so. All right. So,
That's way into biology, boy.
it certainly is interesting, though. I mean, imagine touching down in a country and they're telling you to subject yourself to that test.
Take the swab.
So would you do it?
Who's that? Me? I mean, yeah, under threat of being put in jail in China, maybe, but if it's optional, give me the Krista,
So, but if this
give me the
yeah,
nose test, huh?
if this and you're in jail, you might get the test anyway.
Exactly. So, so,
Wow.
uh, so, so I guess I might have to get deported or something. So, all right, let's resume. Okay. So we were on um question 5. Now we're getting to question 6. Right? And question 6 says that we want to describe the function of a device driver and what is a hybrid network. So let me cut these 2 questions here. Okay, so what is a device driver? Anybody?
So it communicates the hardware with the software.
Right. Okay. So good. So that's mostly correct. It's just how you said it. I know what you mean, but we have to say things exactly. So A, right? A device driver is a software program that allows the operating system to communicate with a hardware device. So maybe we could say something like basically it translates, right? It translates signals from the hardware to be used and exploited by the OS and other applications. So drivers are specific to certain hardware devices, right? What is a hybrid network? Anybody? What's a hybrid network?
Like a mesh network.
Yeah. So a hybrid network is basically what then? What's a mesh then? A mesh is a combination of any 2 network types, right? So a hybrid network, a combination of any 2 network types, right? So for example, a mix between a star and a line network, or a mix between a ring network and a star network, right? And of course, we know that the mix between the ring network and the star network is like a mesh network. Okay. So we go on to the next one. A user is working on a document in a word processor and selects the print option for the word processor. The document begins to spool. What is spooling? So what is spooling? All right. So what is spooling? Anybody ever heard about spooling? Let me see what Alexa says. Not quite. I know I didn't specifically show anything with spooling in so far, so right. So well, yes and no, but that's not the whole answer, right, Alexa? Spooling is essentially, well, let's define spooling for now. Spool, right, stands for spontaneous. I have to find out how to spell spontaneous. Sorry about that. Right, it stands for spontaneous peripheral online. Hold on, now let me get the proper acronym for it. Right.
So it's simultaneous peripheral online.
Spontaneous, not spontaneous. Right. Simultaneous peripheral online operations online. Good. All right, so let me just get my spelling in order, and then we will, I'll just copy and paste here. Simultaneous peripheral operations online. All right, I prefer to ANPOS PRIDHPRL operations online. What is it? This is kind of like a form of buffering. Okay, spooling is a form of buffering so that it really and truly loads up documents or tasks that needs to be done part by part, right? So it's like reading the document in so that we can process part of it, and then we can read another part of the document in. So it's a form of buffering. Let's say that. It is a form of buffering used in hardware devices where parts of the operations to be processed are loaded and handled before more is processed. Okay, so it comes from long ago when memory was yeah, sometimes my brain is not so good, right? Right. Forgive me, Collins, and the rest of students. Right? It comes from a time when memory was very limited in terms of being able to put it on hardware devices. So your printer, for instance, might have had very limited memory, and if you wanted to print a document that was bigger than how much memory your printer had, the document had to spool. So really and truly, it's kind of like breaking up the document into parts, right? Because the computer operates much faster than I/O devices. So you really and truly have to break these documents up into parts and only send parts at a time to be able to process that information. So spooling is really and truly associated with input output, right? And most tightly associated with printers, but this is more like early printers. Everybody understand what I'm talking about? Right? And it allowed for batch jobs to be done because now you could buffer jobs to be able to you could buffer jobs to be able to be done on, multiple printers. So where, spooling was, if you had like a print server, um, you had multiple clients requesting things to be printed. The print server would queue up the jobs, and then the print server would be responsible for sending the jobs. Of course, you can't interleave jobs when you're printing, so it has to be done, serially. And the jobs would be, the print server would send part by part to the printer. So one advantage of spooling is that it allows for printing, right, or outputting to devices that have limited amounts of memory, right? It allows for printing or outputting to devices that have limited amounts of memory, where the data to be sent is larger than the memory available on the device. Everybody's good with that? Everybody understand
Yes.
what I'm talking
Yes,
about?
sir.
All right. So let's go back to page 5. All right. Next up, we have a question on interfaces. This is one of those very very popular questions. Okay. So give one reason why a menu interface might be preferred over a command line interface. So why would we have, or when would we have a scenario where we would prefer a menu interface over a command line interface?
If the device doesn't have like a keyboard or like
Right,
as
okay.
much buttons.
Yes. So for part 1, right, when the device has limited input options, a menu interface may be able to allow the user to select options, right? Menu interfaces. I'll go with the next option that was suggested, right? No, yeah, in terms of menus, sorry. Menu interfaces also are also simpler, so they can be used when when the users have limited technological capabilities.
Experience. Oh, okay.
Yeah, well, capability, right? Capabilities or experience, yeah. And then 2, give one reason, right? So we ended up with 2 reasons here. Give one reason why a command line interface may be preferred, right? So, of course, a command line interface might be preferred for specialized systems where explicit and exact instructions must be entered for optimal, right? Where explicit and exact instructions must be entered for optimal results. A command line interface is is preferred. Okay? And let's go back. Two possible interrupts that can occur while a game is running on a computer. Okay, and then the last one, which is virtual memory, which I don't think I spoke to you all about again as well. So this is kind of like an introduction to virtual memory as well, because we have to talk about paging, etc. Right? So two possible interrupts that can occur, but we did talk about interrupts while a user is running on a game on a computer. Okay, so anybody?
Wait, what's this?
Right? So two possible interrupts that can occur while a user is running a game on a computer. So we can have one like a hardware interrupt. Right? And our hardware interrupt could involve, right, some device on the system has failed, and as a result, the computer needs to give it attention because the game may need it for operation. And then we might have some sort of input-output interrupt, okay, where, of course, the game is waiting for input, right? So the game is waiting for input to proceed. Everybody's fine with this?
Yes, sir.
Yes, sir.
Isa, what is POG?
So you're taking up disrespect from Daniel. Wow.
Yeah, boy. Hold on. Oh, it looks like Daniel has left the class. Look at that. I hope he gets back in. All right. All right, and the last question. A user is running an application that requires more RAM than that which is physically installed on the computer. So this one was, let me just say E. All right, and now we're going to type up F. So a user is running an application that requires more RAM than which is physically installed on the computer. Briefly describe how the concept of paging can be used to solve the memory problem experienced by the user. So let's discuss what paging is. This is F. Is Daniel back in? Daniel?
Yes,
Oh,
sir.
yeah. All right. Daniel, you having network problems? All right. So we're on to paging. All right. And what paging is I just like to illustrate it like this. Sometimes, all right, this is a topic that would be very close to you guys, virtual memory. Okay? And sometimes in a computer system, we know that we might have a limited amount of RAM. So let's say, for instance, what virtual memory is that if this is your RAM here, typically, let's say you have 2 gigabytes of RAM, okay? And let's say, for instance, the operating system is holding up 500 megabytes of RAM. That leaves about 1.5 gigabytes of RAM for various applications on your computer. Let's say, for instance, your antivirus is running. Your antivirus might use up about 200 megabytes of RAM. You have a browser window open, right? You have a browser window open. This might use up about 400 megabytes of RAM because it might be Chrome. Okay? You have Microsoft Office open, that might use up another 400 megabytes of RAM. It leaves you with very little RAM left in your system. Okay, we have 5 and 4 and 4, 13, 15. So we have about 500 megabytes of RAM free, right? I drew this document very unequally, but we'll see. Let's just move everything down a touch. All right, so we have about another 500 megabytes of RAM free here. Let's say, for instance, you start up an application. Let's say you start up PowerPoint, right? And PowerPoint takes up about 400 megabytes of RAM again. And you have 100 megabytes of RAM left on your system. And you decide to start up, let's say, a music player. All right, and the music player might need 200 megabytes of RAM, but right now you're at a minus 100 megabytes of RAM. What is going on in your system? You've used up all the memory that is available in your system. So right now we're actually at a deficit. How is it that your system has not frozen and crashed? Well, the concept of virtual memory allows for your hard disk drive, right? Your hard disk drive to be used as virtual memory. And what this is that this virtual memory, right, will now allow for actual actual items that should be stored in RAM to be stored on your hard disk drive and be read from your hard disk drive. That's not something that you should do unless you have to do it. Okay? If we taking a virtual memory approach to a system where we're using virtual memory is a last effort to prevent the system from being overwhelmed and crashing, right? It's not something that should be run and say, okay, well, I could use my hard disk drive in place of RAM. Of course, newer systems with solid state drives, yeah, solid state drives are pretty fast, but they're still not as fast as RAM. Okay, so because RAM is specifically, it's capacitive memory, so it actually deals with manipulation of electronic signals. Even your solid state, even though it's read via switches, as opposed to the older hard disk drives, which were magnetic, right? If you store something that should be in RAM, on your hard disk drive, it is going to take your computer a long time to read information from your hard disk drive. Think about moving a file on your computer that's 100 megabytes large. I know with solid state drives, it's not that much time anymore, but long time when you had those spinning disks, it used to take a while even to move 100 megabytes from one part of your disk to another part of your disk. So you run into the issue of something called trashing, right? Where, if it is that you store too much information right? And consider that trashing is something really important, right? Trashing is when you have more, it takes longer for you to pull your information from virtual memory than it does to actually execute the application. So even when you start to use virtual memory and your system is using virtual memory only to try to rescue and hopefully allow the process that is using excess memory to run to completion, and then everything else should only run inside of RAM, right? So instead of seizing up your computer and nothing could be done. The process of writing information to the hard disk drive and back to RAM is called paging. And it uses something called page files, which are the small files that represent the data that should be in RAM written to the hard disk drive, right? So your page files are stored on the hard disk drive, and the pages are read from your hard disk drive into RAM, and then of course processed by the processor as necessary. If your, as I said before, if your computer spends too much time reading and writing pages, things could happen, like pages could be lost, or the system could start to really suffer due to trashing. You all with me on this?
Yes, sir.
Yes, sir.
All right. Hold on. All right. So basically, paging is where we have our virtual address space. We know that every location in RAM is addressed. If we have to extend that memory into virtual space, then we have to be able to access that memory still, and that the excess data is written in page files. Okay? Now back to the question, right? A user is running an application that requires more RAM than that which is physically installed on the computer. How does the concept of paging, how the concept of paging might be able to use to solve the problems experienced by the user, right? So we could say here that the excess data data for the applications that should be running in RAM are stored in the page files of the virtual memory of the computer. This virtual memory is stored on this virtual memory, right? Page files is stored on the hard disk drive of the computer, and the virtual memory page files is stored on the hard disk drive of the computer and are accessed and loaded into RAM, are accessed and loaded into RAM when the data is needed, right? This process can be slow, but it can prevent the computer from crashing due to a lack of RAM. Everybody's fine with this? Everybody understand where I'm coming from?
Yes, sir.
Yes, sir.
Right? All right. Okay. So we have about 15 minutes. Wonder if we could tackle part of another question. Anybody have any questions so far?
No, sir.
All right. trying to think about. Let's see if we could just tackle the questions of question 3 and 4, but not the document questions. Not the DFD or ERD question. We'll tackle every other question here, right? So hold 1 second, please. Yeah. Right. So what is involved in the evolutionary development of software? So what is the evolutionary development of software? Anybody can answer.
You might just keep adding on and stray from the original objective.
That's the answer for part 2.
Oh.
So what does evolutionary development of software involve? It's a what approach? What kind of approach is it?
A fountain approach.
Fountain
So it's just
approach.
like small versions of the waterfall approach where users get to access the results
Right.
at the end of the
So
stage.
there's an I word that I was looking for.
Iterative.
Iterative, according to Alexa.
Right. Is an okay. I didn't have the chat open, but thank you,
Yeah.
Alexa. It's an iterative approach to developing software where small changes are made with every iteration before a review is done and more changes / improvements are made. Okay, so evolutionary development of software is an iterative approach where small changes are made with every iteration and every time a little improvement is made. Okay. State 2 problems of using the evolutionary development approach. Now, Collins, one of your answer was good for here. So 2, what did you say, Collins?
Oh, I forgot now. End users would keep on asking for new features and it will stray from the original objective.
Right. So we can have a problem, right? The users may want to add more and more features with each iteration that is outside of the scope of the, let me put original scope of the users might want to add more and more features with each iteration that is outside of the original scope of the what? Of the project. And what else? Right? This form of
It's more
development
time-consuming.
can be time consuming and costly, right? It could be time consuming and costly because of the fact that, of course, you're going over and over there. You mightn't be able to set specific deadlines on certain things, or as you see needs change, right? It might put off your original estimate for development. Next up is, we're not doing the DFD right now. Case tools. Describe 2 ways in which a case tool can be used in software development. So where are case tools used in software development? one advantage and one disadvantage of case. So this was 3, 1 and 2, right? This is 3C, 1, 2. Yes, so describe 2 ways in which a case tool can be used in software development process. Where can case tools be used? Case tools could be used in the design stage. It could be used in the analysis stage. It could be used in, so in the design stage, a case tool to create mockup of interfaces are right, are useful to get an idea of how the final product may work. And of course, we have another one might be in the programming stage, right? An IDE could provide different tools such as code corrections and suggestions and easy ways to build UIs. What is the advantage and a disadvantage of the case tool? An advantage of the case tool would be something like what? Anybody? Why would you want to use a case tool?
Why would you what, sir?
Why would you want to use a case tool?
For greater efficiency and productivity.
Right. So a case tool can case tools right, and I see somebody has messaged. Right, yes. And increase. Okay, let's see. You mean I sound like Mr. Pollard? Okay. So a disadvantage of the case tool. Hold 1 second, please. So should I boot Collins from the class or should I boot Alexa from the class for these comments? All right.
Both of them, to be honest. Actually, no. Collins, just Collins.
Just Collins. Anyway, yes, the disadvantage is that the disadvantage of the case tool, sorry. Yeah, I have a brain fog going on, eh? I don't know what's going on with me these days. I'm just super tired and I feel like I could have used a midterm break and, Carnival didn't come and the school didn't give us anything. So, I am not firing on all cylinders. Right? A disadvantage of the case tool is that developers could get dependent on the case tools and may not be able to work without them. Okay, so you kind of get a dependency on the tool. It is now 7 minutes to 3. Let's just talk out the other answers. Maybe we'll write it down in next class. What are functional requirements? Anybody could tell me that quickly? What are functional requirements? You could just talk it out, folks.
Like code needed for the software to operate.
So we're looking at really and truly the business rules. Functional requirements are the tasks that the software should be able to do, right? They should be able to do to be able to, of course, to adhere to business rules, etc. So the tasks that are actually the important task, the main task of the software, right? As opposed to non-functional requirements, which are considerations for things like efficiency and security within the system. Those aren't really the objectives of the system, but they are important in terms of what the system can provide. So non-functional requirements are more like supporting requirements of the system, whereas functional requirements are the actual task that the system must do. So how do we obtain functional requirements? Through an analysis. How do we obtain functional requirements?
Look at the problem definition.
Not really. The problem definition is just a description, Don't think if you're thinking about it in terms of the SBA, you have to do your fact finding. So you obtain your functional requirements through
questionnaires.
Right, through your questionnaires and your interview, and observing the system as it already exists, so that you get an idea of what are the important activities within the system. Understood?
Yeah.
All right, so we'll pause it here for today, and we'll do the rest of these later. So yeah, Tarek is correct. It's data collection and questionnaires, etc. Any questions? Any questions, people? Okay, so that's it for you and me today. I will see you all on Wednesday. All right, I'll see you all on Wednesday, and Godspeed. Bye-bye. Have a good one.
I say,
Same to you.
you too.
Bye-bye.